Division of surds. If a fraction has a surd in the denominator, it is usually best to rationalize the denominator. To rationalize the denominator means to make the denominator into a rational number, usually a whole number. To do this, multiply the numerator and denominator of the fraction by a surd that will make the denominator rational. What this statement means is that the examples we have here, 6 over root 3, 7 over root 18, and 5 over root 5. In each case, the denominators are surds, and of course, they are square roots of irrational numbers. Or rather, sorry to say, this square root of non-perfect squares. So this surd, if you have to get the exact value, if you have to get their value, you're going to have values that are not ending or that are inexact, so they are irrational. So to make our work not to be cumbersome, we need to rationalize the denominator. How do we do that? We rationalize by multiplying the denominator, multiplying both sides, both numerator and denominator, by the denominator. Once we do that, we're going to have a value that will be rational after we've multiplied both sides by the denominator. So for instance, if we have let's say a over root b. Now okay, let me use real numbers. Let's say 2 over root 5. Now you discover that this value here is a square, is the square root of a non-perfect square. So if you punch root 5 in your calculator, you're going to have a value, let's assume, let's say 3.1423, on and on continuously. So this is an irrational number. In the first lesson, I talked about rational numbers and irrational numbers. So we need to make this a rational number, and rational numbers are numbers that the values are exact. They do not have, they don't continue indefinitely. They could be single numbers, they could be just few numbers, maybe 0.37, but the thing is that they are exact. You don't have to keep calculating, and the value doesn't have to extend indefinitely. But for irrational numbers, they are not exact, like the value for pi, which is 22 over 7. By the time you do your long division, you discover that it will give you 3.142 continuously the longer you go on with the calculation. So pi is an example of an irrational number. Same thing with square root of non-perfect squares like root 2, root 3, root 4, and the rest. They will give you answers that are indefinite, so they do not have ending. Their values don't have ending. They are not exact. So now this irrational. Now the idea of rationalization is to make the irrational denominator to become a rational number, and this can only be achieved if we multiply both the numerator and the denominator by the surd itself, which is root 5 over root 5. So 2 times root 5 will give us 2 root 5. Then root 5 times root 5 will give us root 25, which is also equal to 2 root 5 over 5. Now 5 is a rational number, but root 5 is not a rational number. So this is the idea of rationalizing the denominator in order for us to carry out division involving surds. So if a fraction has a surd in the denominator, which is like the examples we have here, it is usually best to rationalize the denominator. To rationalize the denominator. To rationalize the denominator means to make the denominator into a rational number. So here initially the denominator was irrational, then we multiplied both the numerator and the denominator by the surd, which is the denominator. Now this is how we go about rationalizing the denominator. So at the end of the day, what we got as denominator is no longer an irrational number but a rational number. So that's what we mean here when it says to rationalize the denominator means to make the denominator into a rational number. So here it was irrational, but now the denominator is a rational number, and this we got to this point by multiplying both sides, multiplying both numerator and denominator by the surd, which initially was the denominator. So let's apply same principles here. So solution, so a 6 root 3 is equal to, so we rationalize, we're going to have 6 times root 3 over root 3 times root 3. So this will give us 6 root 3 over root 3 times root 3 will give us 3. So whenever we have something like a same sort multiplying each other, like root 3 times root 3, this will simply cancel, and then we have just 3. Or in case you don't want to go back this one, so you just say, okay, root 3 times root 3. Just like saying this will give us root 3 raised power 2. These two cancel the square root sign, so we have 2 left. Or remember from indices, root 3 squared is equal to 2 raised to power 2, where our square root sign in indices is the fractional power, which is 1 over 2. So 2 multiplied by 1 will give us 3 raised to 2 over 2. 2 here, 1, 2 here, 1. So this will give us 2 raised to power 1, which is equal to 3. Or we can simply say root 3 times root 3 equals to 3, that's root 3 times 3, which is equal to root 9, that's equal to 2. So any of the method. So now we have rationalized the denominator, so it's now a rational number. We can simplify for that 3 here 1, 2 here 2. So this is equal to 2 root 3. That's the answer for A. B, 7 root 18 is equal to 7 over root 18 times root 18 over root 18. So 7 root 18 over root 18 over root 18 will give us 18. This can be simplified further to give us 7 times root 9 times 2 over 18. And this will equal to 7 times 3 times root 2. And this will give us 18. And then this will give us, so 2 here 1 into 18 is 6. That will give us 7 root 2 over 6. C, 5 root 5 equals to 5 root 5 times root 5 over root 5. And then so this will give us 5 root 5 over 5. 5 here 1, 5 here 1. So our final answer is root 5. Given that root 2 is equal to 1.414 and root 3 is equal to 1.732, simplify A, B, C. Solution. So A is equal to 5 root 2, 5 over root 2. The first thing is to rationalize this surd, or rationalize, or to simplify by rationalization. So 5 over root 2 times root 2 over root 2. And this will give us 5 root 2 over root 2 times root 2 will give us 2. Now this will be our final answer, but we're given a value for root 2 here. So we're going to say but root 2 is equal to 1.414. So therefore 5 root 2 over 2 is equal to 5 times 1.414 over 2. Zero point 0.535. 0.535. be 6 root 3 is equal to 6 over root 3 times 3 over root 3. And this will give us 6 root 3 over the 3 times 3 is 3. 3 here 1 into here is 2. So that will give us 2 root 3. So but root 3 is equal to, from what we were given here, 1.722. 1.722. 1.722. So we say therefore 2 root 3 is equal to 2 times 1.722. That is equal to 3.464. 3.464. And C 7 root 2. 7 root 2. So 7 over root 2 times root 2 over root 2. 7 times root 2 over root 2 times root 2 is 2. Then we say but root 2 is equal to 1.414. So we say therefore 7 root 2 over 2 is equal to 7 times 1.414 over 2. And that is 4.949. 4.949. Solution A root 18 over root 2 equal to, remember the division rule, that's root n over n is equal to root n over root n. Similarly, root n over root n equals to root n divided by n. So we can go about this. We can rationalize or we follow this rule. So let's follow this rule first of all. So root 18 over root 2 is this part. So we'll equate it to 18 over 2. So this will give us 18 divided by 2 here, 1, 2 here, 9. This will give us root 9, and that will give us 3. Alternatively, you can say root 18 over root 2. To rationalize the denominator, this will give us root 18 times root 2 over 2. And root 18 times root 2 will give us root 36. Root 36 over 2. Where root 36 is equal to root 36 is equal to 6. So now we give us 6 over 2. 2 here, 1, 2 here. So that's equal to 2, the same as what you have here. So B root 5 over root 2. So we can do, okay, for this particular case, it's similar to, alright, this part and here. So this will give us, this root 5 root 2, this will give us, you can say this will give us root 5 over 2, and that is equal to root 2, 5 over 2 will give us either 2.5 or give us root 2 whole number 1 over 2. Any of them is correct. That is or this is correct. And okay, so that's that there. Or we can solve it like this. Alternatively, we can say Alternatively, we can say root 5 over root 2 is equal to root 5 over root 2 times root 2 over root 2. And this will give us root 10 over root 2 times root 2 will give us 2. And of course, this root 10 over 2, or let's say 1 over 2 root 10. So which is the same thing as what we have here. The value here looks as if it's not exactly what you have here. Remember, this one was a same value. If you punch your calculator with 10 over 2, you get the same value as when you punch your calculator with 2.5. So you're going to get the same answer. Just as for this one, we make use of rationalization method, while this we made use of the division rule of Surds. So C was 16 over 7. 16 over 7. So from our rule, where we have root m divided by n, we're going to have root m divided by root n. This will give us root 16 over root 7. Root 16 is 4 root 7. Now we need to rationalize this denominator. So to do that, we're going to say 4 over root 7 times root 7 over root 7, which is 4 root 7 over 7. Final answer. Okay. And D. So D is 5 root 7. 5 root 7 times 2 root 3 over root 45 times root 21. So these, the surd here, or the numerator, they are in a basic form, but the denominator, surd here, they are not in their basic form. So let's simplify this part. So this will give us 5 root 7 times 2 root 3 over, this will give me 9 times 5 times 3 times 7. And of course, this will give me 5 root 7 times 2 root 3 over root 9 root 5. Root 9 times root 5 times root 3 times root 7. And this will give me 5 root 7, 5 root 7 times 2 root 3 over root 9 is 3. 3 times root 5 will give me 3 root 5 times root 3 times root 7. Since it's multiplication all through, then we can cancel common terms. So root 5, I have root 5 here, there's no root 5 here, so but I have root 3 here, and there's root 3 here, there's root 7 here, there's root 7 here. So what is left is 5 times 2. So this is 10 over 3 root 5. So I'm going to rationalize the denominator. So this will give me 10 3 root 5 times 3 root 5 over 2 root 5. So 10 times 3 is 30 root 5. And this will give me 3 times 3 is 9. Root 5 times root 5 is 5. So 9 times 5 will give me 45. And now, what can go? 5 can go. So 5 here, 6. 5 here is 9. 3 here, 2. 3 here, 3. So this would be 2 root 5 over 3. That's my final answer. 2 root 5 over 3. E, 10 root 2. 10 root 2 over root 5. So let's rationalize this. 10 root 2 over root 5 will give us 10 root 2 over root 5 times root 5 over root 5. This will give us 10 root 2 times root 5. That gives us 10 root 2 times 5. Root 5 times root 5 will give us 5. 5 here 1, 5 here 2. Which gives us 2 times 5 is 10. 2 root 10. And f1 root 3 is equal to 1 over root 3 times root 3 over root 3, which is equal to root 3. Root 3 times root 3 is equal to 3. And g, we have 2 root 3 minus 6 over root 3 plus 3 over root 27. So here we have a surd as denominator. Here we have surd as denominator. So we are going to rationalize each of these surd individually. So 2 root 3 minus 6 times root 3 over root 3 root 3 times root 3 plus 3 times root 27 over root 27 times root 27. So we are going to have 2 root 3 minus 6 root 3 over 3 plus 3 root 27 over 27. Now if you go on to 2 here 1, 3 here 9, 3 here 1, 3 here 2. So we can go, so now we have 2 root 3 minus 2 root 3 plus 1 over 9 plus 1 over 9 root 27. So 2 root 3 minus root 3 we cancel out to give us 0. So our final answer is equal to root 27 over 9. But we can still simplify this further. So root 27 over 9 is equal to, this will be equal to root 9 times 3 over 9. And that will give us root 9 times root 3 over 9. Where root 9 is 3, 3 times root 3 over 9. So 3 here 1, 2 here 3. And this will give us root 3 over 3 or 1 over 3 root 3. Okay. So that's our final answer is 1 root 3 over 3 or 1 over 3, which is 1 over 3 times root 3, which is same thing as this one. I feel that's our final answer.